So this is the Math 095 Exam 3 review, and it covers chapters 6 and 9. So 6 was functions, and so remember that a function is for every x there's only one y, or for each input there's only one output, is sort of the definition. Relation is just a set of ordered pairs, so it's everything. It could be a function or not a function. For domain, that's our independent variable, usually x, but it could be named something else, but it's our input variable, so the domain is a set of all the inputs, and likewise the range is a set of all the outputs, or the dependent variable, or generally y. So domain x, range y. So for these first 6 or so, it's determine whether or not the data represents a function. And so looking at this one, we got a couple of b's over in the x's, so that's usually the heads up that it's not going to be a function. So when the input is b, the output could be 3 or 7, so this would be not a function. Here, all of the outputs are 2, but that doesn't matter because when x is 0, y is only 2. When x is 1, y is only 2. So you can have repeats in y, but repeats in x's are going to make it not a function. So this one would be a function. C, same thing, just in a ordered pair side by side instead of a t-table. So looking through the x's 2, 3, 4, 5, so I have all individual x's, no repeats. So that's going to be a function. Even though there's, when x is 4, y is 5, when x is 5, y is 5, it's cool because it's only 5 in each case. Here, when x is 2, it could be 3, or when x is 2, it could be -2, so that is not a function. For graphs and functions, that's the thing where we do the vertical line test. So if I only hit the graph once, anywhere I draw a vertical line, that would be a function. But here you can see I can hit the graph in 2 different places. And what that means is for that x right there, there's a y right here, and then a second y right there that go with this value of x. So this is not a function. Okay, number 2 is write the following sets in actually not inequality, just interval notation. I keep meaning to take inequality out. So interval notation, this would be -infinity to 5, and I'm using a parenthesis because of the open dot. Then union that with 7 to 9. And then brackets there because of the closed dots. And then remember, infinity always gets parentheses. And then this one would just be from 2 up to 7. And then bracket on that side. Domain and range, so that's where we use this interval notation. So domain is the set of our allowed x values. And so this one, it ends here, but that endpoint wouldn't be included because of the open dot. And this side, notice it does have an arrow, so that means it goes on forever. And so the domain on this, the farthest to the right that I get is right there at -6. And then that goes forever, right? Because this line's going to keep going. So that little green arrow I just made there would be my domain. So this is going from -6, not inclusive, to infinity. And then the range on this, the lowest point looks like it's at 5. And then I always get the question, do I include it or not? Yep, because if I asked you when x is 0, what's y, you would tell me, sorry, -5. And that point exists, every point on the line exists. So we'd go from here, and then this is going to climb forever. So that would be our range. So this is going from, including, -5, and then to infinity. Okay, these are the matched ones I would have you guys try. So is it a function or not? So looking down the x's, it looks like they're all no repeats, so this would be a function. Don't fall for the 2 4s there. Function or not, 2, 3, 4, 5, yep, so that is a function. And that is pretty much not a function because anywhere I draw a vertical line, I hit it more than one, or I hit it twice, except right at the edges. So that is not a function. Okay, again, skip inequality. So write in interval notation, so this is going to go from -infinity up to and including 4. and then union that with 6 to infinity. And bracket solid dot, parenthesis, open dot. Same idea down here, so this will be 2 to 5, and then union 8 to infinity. So domain and range again. So it looks like for my domain, 6 is as far to the left as I go, and this thing's heading forever down, but it's also heading forever to the right. So that's going to make this be my domain. Oops, that should be open, sorry. So from -6 to infinity, open. And then my range, the lowest it gets, so this is a little sneaky because the arrow stops up here, but the arrow means it keeps going, right? So the farthest down it's going to get is -infinity. So it's going to come from -infinity and come up, 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 and then stop right there on 7. So this is going from -infinity and up to 7. Okay, 6.2. So this was function notation, so we pick up f of x and lots of kind of evaluating and solving for the x. So this first one is solve f of x equals 4. So the good thing to remember here is when we have f of x, that is like y. So what this is saying is basically solve for when y equals 4. And that's referencing this chart over here. So you come over to when y is 4, and it looks like x is 14. Find f of 8. So remember that now the 8 is replacing the x, so this means x equals 8, and we're looking for, when we plug in 8, what comes out. And so when we plug in an 8, it looks like we get out 1, so y is 1, or f of 8 equals 1. Same idea down here, just now it's based on a graph instead of a table. So evaluate f of 0, so that means that x equals 0, so we're looking for the y value when x is 0. So when x is 0, it looks to be y is 4. Evaluate f of 2, so when x is 2, it looks like y is 3. So this again, that's y equals -1. And so what would make it come out to y equals -1? So it looks like the only thing, -1 is down here. So it looks like just right there is the only spot where it's ever -1. And so that's at x equals 6. And then solve f of x equals 2, so that would be like y equals 2. So if I draw a line through there at 2, so it looks like right here and right here. So notice we can get more than one answer for the x. So x equals, looks like -5 or 3. Okay, and I would have you guys try this one in class. So evaluate f of 4. So when x is 4, it looks like y is 4. Find f of -3. So -3 looks like -2. Solve f of x equals 3. So that would be right here. So that's the line y equals 3, which is what this is saying. And so the two places it intersects is there and there. It doesn't intersect there because the graph isn't there. That one's a hole. So this would be x equals 3 and 5, I think. And this one is f of x equals 0, so that's basically finding the x-intercepts. So we're looking for, this would be y equals 0. This is the x-axis. So it looks like we got 3 points of intersection. I think that one's supposed to be at -4. Oops. 2 and 6. And then I had you find domain and range on this just because it's good to practice. People have a hard time on the test with domain and range. So the domain is going to be from right here to right there, because that's my farthest left and my farthest right. So I want to not include the -6, and I want to include the 6 because open dot solid dot. And then the range, the lowest the graph goes, looks to be -3. And it goes up to 4. Okay, so the next step is the algebraic expressions and function notation. So this first one is g plus h, and then this means evaluated at -3. So this is the same exact thing as g of -3 plus h of -3. And so it doesn't mean multiply by -3, it means evaluate at. And anytime there's those parentheses after these, it's always evaluate. If they wanted you to multiply, they put the 3 in front. So I can do it one of two ways. I could add these together first, which is actually probably easier. 2x minus 1 plus, that's my g, and then h is x minus 5. So 2x and x is 3x. Hi, Squawk. My cat is visiting. Equals 6. And then evaluate that at 3. And so that would be, or sorry, -3. So that would be -9 minus 6, or -15. Hi, Squawk. He's feeling very chatty, sorry. Okay, so the next one is g times h evaluated at 3. So that one, I think I would probably just plug in the 3 because it's easier. And then set up kind of like it's going to be a FOIL, except I'm just plugging in this 3 instead of doing the x's, because there's really no reason to FOIL it all out, because this just could be some number times a number. So this is 6 minus 1, so that would be 5. This is 3 minus 5, so that'd be -2, and then 5 times -2, -10. So you can either do the algebra and then plug in the number, or just go straight to plugging in the number. And depending on the problem, sometimes one is easier, sometimes the other is easier. Okay, so then these ones are plugging in something kind of other than a number. So this is saying find f of x minus 3. So this whole thing right here is the new x. X minus 3 is the new x. So it's going to go there and there. So then f of x minus 3, I'm going to start it down here just to make sure I have enough room. X minus 3 squared minus, and then 5, x minus 3 plus 6. So then we expand this out and then simplify, and then we're done. I'm going to use special products here, so I'm going x times x is x squared, x times 3 and then double it makes 6x, 3 times 3 makes 9, and I'll distribute that 5, so minus 5x, and then minus minus makes plus 15. I should say, if you don't like special products, you can also write this out, x minus 3, x minus 3. If you have to take any algebra classes after this one, though, I'd encourage you to just learn special products because they're very handy. And then plus 6 here on the end. And then collecting terms, I got x squared plus 6x minus 5x. I think that's it for those. So that'll be plus x. And then 9 and 6 is 15, and 15 makes 30. So plus 30. And you know what? I just spotted a sign. When I was doing my special products, I was thinking about I should go back and show that, and that should be a minus. And then this should be a minus 11. So pretend like that is, there we go. So for D and C get confused a lot. So here, the x minus 3 is all in the parentheses, so it's being substituted for x. Here, this just says take f of x. F of x is this whole thing. That's f of x, and then subtract 3. So it's actually a really easy problem. So this would just be x squared minus 5x plus 6 minus 3, and then x squared minus 5x plus 3. Okay, number 4. Pick up composite functions. So remember with composites, there's an inside function, in this case g of 5. We do that step first and figure out what g of 5 is. So we plug 5 in for g, so that'd be 2 times 5 minus 1. So g of 5 is 10 minus 1, or 9. And then 9 is g of 5, right? G of 5 equals 9. So now I take this and I plug it right back there. And then that means I'm finding h of 9. So in other words, we get the inside answer and we put that into the outside function and we get the final answer for these. And then they also have 2 different notations. This is the one I prefer, but this could have also been written h of g, looks like hog, of 5, and that would be the same thing. So sorry, I've done g of 5, found out that was 9, so now I'm plugging 9 into h, and that's going to be 9 minus 5, or 4. So 4 is the answer for the whole thing. Over here, h of negative 1, so we'll do negative 1 minus 5, that would be negative 6, and then I'm supposed to find f of negative 6, because this goes back in for h of negative 1. And so that's going to be this one, so that's negative 6, and careful, that's quantity squared when you're substituting, and then minus 5, negative 6, plus 6. So 36 plus 30 plus 6, or 72. Okay, and these are the ones that have you try. So for this one, it's 2 different numbers that we're substituting, so we can't do the algebra first. But this one, because they're both 5s, we could if we chose to. So f of negative 2, so plugging negative 2 in here. And also these are the ones that have you guys try. Don't remember if I said that. Oops. And then we're subtracting, so we have to be really careful and open that parenthesis right there, and that's what everyone forgets to do. And then this is g of 4, so 4 plus 3. Because otherwise, without the parenthesis, it's minus 4 plus 3 instead of minus 7. So over here, we're going to go negative 2 times negative 2 makes 4, and then that'll be a minus 8, minus 3, minus 7. And so let's see, that is 15, 18, so 4 minus 18 should be negative 14. And this one, I think it's easy just to plug it straight in. So we'll do g is 5 plus 3 over h, so 2 times 5 minus 2. And that is 8 over 10 minus 2, 8. So that equals 1. Okay, these ones would still be you guys. So f of negative x seems like kind of a funny thing to find, but actually you do end up doing that. So plugging negative x in for x, because whatever's in there is just the new x. So plus 4 times negative x minus 3. So this one would be positive because negative squared. That one flips to negative and minus 3. This one, so f of x plus 2 plus 2. So it's kind of both of the ones combined into one. So that would be, started down here, x plus 2 is going to go into that. And then at the end, I'm going to add a 2. So this will be x plus 2 squared plus 4x plus 2 minus 3, and then that's the plus 2. And then I just have to clean it up. So special products again, x squared plus 4x plus 4 plus 4x plus 8. Minus 3 plus 2 would be minus 1. And then x squared, 4x and 4x, so 8x. 4 and 8 would be 12, minus 1, 11. Okay, and then back to the composites for you guys. So h of negative 3 would be our first step, do the inside, and that is 2, negative 3 minus 2. So that is negative 6 minus 2, or negative 8. And so then that's our inside, so then we have to find g of negative 8. So plugging that back into g, I got negative 8 plus 3, or negative 5. Next one, f of g of negative 1. So that's going to be g of negative 1 is negative 1 plus 3, or 2. And then that goes back in, and we find f of 2. So f of 2, 2 squared plus 4 times 2 minus 3. So 4 plus 8 minus 3, or 9. Okay, section 6.4 was doing algebra, and with the functions, instead of so much evaluating, this is just more combining. So this first one is f minus g plus h. So there's f minus g. Again, anytime you do a minus, open a parenthesis, 5x minus 4, and then plus h. So x squared plus 3x minus 4. And I'm going to go ahead and run that negative through there. And then I'll just combine like terms. So I got x squared, I have an x, a minus 5x, and a plus 3x. So that's 4x minus 5x, a minus x, and then a minus 1, a plus 4, and a minus 4. So those cancel, and minus 1. This one is f times g, so it's just a FOIL. And it's not times x, it's of x. So it's the same as saying f of x times g of x. So x minus 1, and then 5x minus 4. So 5x squared outside minus 4x inside minus 5x last plus 4. And then just collect terms. 5x squared minus 9x plus 4. Okay, so then we have h right here minus f times g. So h is x squared plus 3x minus 4. And then f times g I just did back on this page. So I'll just copy my own work. And then subtract those. So x squared minus 5x squared, so that's going to be minus 4x squared. 3x minus a negative 9, so that would be plus 9, so plus 12x. And minus 4 is minus 8. And if you prefer, you can definitely rewrite the signs if that's easier. H over f, so that would be x squared plus 3x minus 4 over x minus 1, but we have to check and see if this reduces, and it does, so that's going to be x plus 4, x minus 1, so if I can factor, then that allows me to cancel, and those do reduce, so x plus 4. These are the matched ones that have u tries, so this is going to go h, x squared plus 2x minus 24, minus g, so minus x minus 4, and then minus f. Again, it's just like h of x minus g of x minus f of x. And so I'm going to rewrite the signs on that, just so I don't lose people. And that becomes a plus, and that becomes a plus. So then we got x squared, 2x minus 2x, so those cancel, minus x, minus 24 plus 4 plus 1. So I think negative 19. F times g, so again just a FOIL. So 2x minus 1, x minus 4, f times g. So 2x squared minus 8x minus x plus 4. Combine our terms and get 2x squared minus 9x plus 4. This one has that same thing where it uses from the last question, so I'll just copy it down here. So h is x squared plus 2x minus 24, and then that's going to be minus 2x squared minus 9x plus 4. And distributing, so minus 2x squared plus 9x and minus 4. So x squared minus 2x squared is minus x squared, plus 2 plus 9 would be plus 11x, and minus 24 minus 4 minus 28. H over g, so let's see, we got x squared plus 2x minus 24 over x minus 4, and again it's factors and reduces, so x plus 6, x minus 4, x minus 4. So final would be x plus 6. And then we're back to composites. This is one like what we saw in 6.2, and it's just to kind of have it next to the other one from 6.4 for kind of comparison. So when there's a number in there, that's where we went f of 3, and we found that, which would be 3 minus 1 or 2, and then we put that into the outside function. So h of 2. So 2 squared plus 3 times 2 minus 4, or 4 plus 6 minus 4, which would be 6. So that's when we have a number. We're evaluating these functions at 3. This is different. So this is a composite of, this was a composite of h and f evaluated at 3. This is just a composite of g and f. So f is going to be the input of g. So another way of thinking of this is f of x is replacing all the x's in g. F of x is x minus 1 right here. So we're finding g of x minus 1. So this is going to go in right here for the x. So that would look like 5, and then x minus 1 minus 4. So that's the new x right there. And then 5x minus 5 minus 4, and just combine our terms. Okay, so this one is h of g of x. Again, the other notation would be h of g of x. So this means that g of x is going into h, or we're finding h of 5x minus 4. So that right here is going in there and there. So that's going to look like 5x minus 4 squared plus 3, 5x minus 4, and then minus 4. So expanding this, again, you can write those side by side, and you can FOIL, but I encourage you to learn special products. So special products, this would go a times a, so 5x times 5x, 25x squared, and then it goes 2ab, so that's 5 times 4 is 20, and then double it makes 40x, and then b times squared, so b times b plus 16. And then distributing 15x minus 12 and minus 4. And then from there I just have to collect, so let's see, this is going to be 25x squared, and then minus 40 plus 15, so that's going to be minus 25x, and then that's 16 minus 16, so those all just cancel, so that would be it. Okay, and then these are the three I'd have you guys try. So again, one where we're evaluating, so f of 3, that's going to go right there. 2 times 3 minus 1, so that's 6 minus 1, or 5. And then find h of 5. So that would be down here, 5 squared plus 2 times x, so 2 times 5, minus 24. And that's 25 plus 10 minus 24, so it should be 11. This one, g of f of x, so that's the same as saying g is going to be evaluated at f of x. So g is going to be evaluated at 2x minus 1. So that would just be 2x minus 1 for the x minus 4. So it's just 2x minus 5. And then h of g of x, so this is going to be h of x minus 4. So that would look like x minus 4 squared plus 2x minus 4 minus 24. And we just have to clean it up. So that'll be x squared minus 2 times, well, at 4 times x and then double it. So that's 8x. So that formula again is, this is a minus b squared. So it's a squared minus 2ab plus b squared. That's what I'm doing in my head. So x times x, and then 2 times x times 4, 8x, and then 4 times 4, b squared. And then 2x and minus 8, minus 24. And like if your next class is either 102, 141, or 116, do learn those. They'll make stuff easier for you. X squared there, minus 8 plus 2, so that's minus 6. And then we got 16 minus 32, so that's minus 16. Okay, so this is the second half of the review, chapter 9, and starting with 9.1 and 9.2, which were completing the square and quadratic formula. We saw 3 methods of solving in this section. We had the square root property, which was nice when we had chunk of stuff squared equals a number. We were able to root both sides. Completing the square, this is good when we have this ax squared plus bx plus c. If a is 1 and b is even, this will get you easier math generally than the quadratic formula. I'll go through the steps when I do an example. And then our third method was the quadratic formula, and this is kind of the last thing you want to try. And so if a isn't 1 or b isn't even, then this is going to be the best bet. And then also, as we go through chapter 9, remember that factoring works, and so we're going to see that in 9.4. Everything in that section is going to factor, and a lot of times we'll try to make those harder than they should be because we just spent a couple of sections doing this. So, okay, first problem is just 2 terms, so that means I can easily isolate the x squared. So I'm going to bring the 4 over to the other side and then divide the 49 on both sides. So that'll give me x squared equals negative 4 over 49. And then from there, I can use the square root property, root both sides. Got to remember the plus or minus. So that gets me plain x equals plus or minus. There's a negative, so there's going to be an I, so it'll be 2/7 I, or 2I over 7, either way. The second one, so it doesn't factor. There aren't 2 numbers that multiply to 24. It had to be negative 8. A is 1 and b is even, so I would complete the square. And so remember, the first thing you do is you bring the 24 over to the other side. And then we take half the middle, half of 8 makes 4, square it, 16, and then we add that to both sides. And now this piece is going to factor to, x, so I was thinking to point out it's a minus b quantity squared. And so these always factor down to one of these perfect trinomial squares. So x minus 4 quantity squared equals 8. And then we can root both sides. And I just noticed that negative I'm missing. let me get that. Should be a negative 8. And then square root of a square makes just the x minus 4. And then we're going to have plus or minus 8. Remember, this is like the same thing as plus or minus negative 4 times 2. So I'm going to bring the 4 out as a 2, the negative out as an I, and I'll leave behind root 2. And then I just have to bring the 4 over. Okay, so number 3 is a little different in that it has a GCF. And so I could factor the 3 out front, but since I have an equal sign, I can also just divide the 3 out. I couldn't do that if it was an x I'd have to keep, but just a constant like that I can divide through. So 3 goes into 3 once, so that's going to be a plain x squared. 3 into 15 would be 5x, and 3 into 6 would go minus 2 equals 0. And so in this case, a is 1, but b isn't even, so I would do quadratic formula. So it's going to be x equals negative b, so negative 5 plus or minus 5 squared minus 4 times a is 1, and c is negative 2, all over 2a. So that is x equals negative 5 plus or minus 25. Minus times minus is going to make a plus 8, and then over 2. X equals negative 5 plus or minus root 33 over 2. Okay, so this one I got to do a little bit of work to get it in the form. So I'll go ahead and FOIL this out and incorporate the 4 over. So it's going to be 4x squared, and then minus 2x minus 6x minus minus makes plus 3 equals negative 4. And I'll collect terms and bring the 4. So that'll be 4x squared minus 8x, and adding the 4 would be a plus 7 equals 0. And so putting all that in the quadratic, I'm going to get x equals negative 8, so that's going to be plus 8, plus or minus negative 8 quantity squared minus 4 times a is 4, and then times c is 7, all over 2a, 2 times 4. So x equals 8 plus or minus 64 minus 112 over 8. I'll come up here with it. X equals 8 plus or minus 64 minus 112 is negative 48 over 8. And it might be tempting to cancel 8's there, but you can't cancel under the radical. You have to have stuff out front to be able to cancel something outside of the radical. So we'll think of this 48 as a 16 times 3. And then that's going to bring out a 4, an I from the negative, 3 left behind over 8. And so now, if there's something that divides, or whatever the biggest thing is that divides into all 3 of those, that's what we can cancel. So 4 goes into everything, so 4 goes into 4, 1, 2, and 2. So the final on this will be x equals 2 plus or minus, I don't need the 1i, so I'll just write I root 3 over 2. Okay, so 2 terms, that's where we can use square root property. So I'm going to bring over the 32, and then I'll divide the 25. And so then I have x squared equals negative 32 over 25, and root both sides. And we got x equals plus or minus 32 is 16 times 2. So it's going to be a 4i root 2 over 5. And then this one leads with a 1, has an even middle term, so we'll do complete the square. And so I'm going to just move the 1 over, and these are the matched problems that I'd be having you try in class. So half of 6 is 3, and then 3 squared makes 9. And that's going to make x plus 3 squared equals 8. And then I'll root both sides. That gets me x plus 3 equals plus or minus 8. I'm going to write it as 2 root 2, and then just bring the 3 over. Okay, so this is one with the GCF. So again, I could factor it out, or I could just divide both sides by 2. So 2 into 2 once, so x squared, 2 into 12 6 times, and 2 into 8 4 times. And so it has an even middle term, so I'm just going to complete the square. And so it's another 6, so half of 6 is 3, and squared makes 9. And then x plus 3 squared makes 13. And then we can do our root. X plus 3 equals plus or minus root 13, and bring the 3 over. Here we need to do a little FOIL, so x times x is x squared. Outside I get 3x, inside I get 6x, and then at the end I get 18 equals negative 1. Collect terms, so it'll be 9x, and then adding this over I'm going to get plus 19 equals 0. And then this is 1, but that's odd, so I'm going to do quadratic formula. So x equals negative 9 plus or minus 9 squared minus 4 times a is 1, and then 19 all over 2 times 1. So x equals negative 9 plus or minus 81. 4 times 19 is 76. And x equals negative 9 plus or minus square root 5 over 2. Okay, so that gets us to 9.3. And probably the biggest thing on the test that people do wrong on this is just have absolutely no memory of ever having done it whatsoever. So this is where we're given the answers and we're working backwards to the solution. So the trickier piece is the fraction. So let me remind you how to do that, just kind of off to the side here. So if I have x equals negative 3/5, I multiply both sides by 5, and then those cancel. And then from there I can add over the 3. I get 5x plus 3 equals 0. If you can do that in your head, you're more than welcome to not show that work. But I just kind of think of it as I'm going to multiply the 5 and then add or subtract whatever's in the numerator. But so then what we do is we just set all these up as their factors, and then we FOIL them, and then that gets us the equation. So this will be x plus 2. This would be x minus 2. So factors and zeros always have opposite signs. And then 5x plus 3. And then equals 0, because it's an equation, it has answers, so it has to have an equal sign. If I have a pair like this, I always want to do those first, because that's just going to be a nice x squared minus 4. And that makes for a little bit easier FOIL on the next line. So doing this out, I got x squared times 5x, so 5x cubed, and then 3x squared minus 20x minus 12 makes 0. This one, pretty similar. It has roots, but it's not really any different. So this will just be x minus root 3 and x plus root 3. And, oops, x, that'll be minus 2 equals 0. So this will just be a squared minus b squared again. So x squared minus root 3 squared is just minus 3. So the roots aren't really any harder. And then again, just FOIL like we did here. So x cubed minus 2x squared, and then minus 3x minus a minus makes plus 6 equals 0. And then these are the matched ones. So I won't go through the steps on these. I'll just say it's going to be 5x and then add the 4 over plus 4. And same thing here, 5x but then minus 4. And that'll be x minus 3. So that's our difference of squares. So it'll be a squared minus b squared. So 25x squared. Sorry, these are the two matched ones I would have you guys try. Minus 16. And then x minus 3. And we'll just do that out. So it'll be 25x cubed. 75x squared. Minus 16x. Plus 48. Equals 0. And then this one with the roots, not a big deal. So x minus root 5, x plus root 5, and x plus 2 equals 0. So this will be x squared, and then root 5 squared again is 5, and then just times the x plus 2. So this will be x cubed, and then plus 2x squared minus 5x minus 10 equals 0. Okay, for these ones I prefer to reverse complete the square. So I'm going to think of this as x equals plus or minus 3i. I could set this up as x plus 3i, x minus 3i, and FOIL. It gets a little ugly on this one, so I like this version better. So then from here to undo that plus minus, I just square both sides. And so we're basically going right back up the square root property. So then this is x squared, plus or minus is gone, 3 squared makes 9, and then I squared, which is negative 1. So that's really negative 9, and then bringing that over, x squared minus 9 equals 0. I'll do the same method on this. So this is going to be x equals 3 plus or minus 4i. So the first thing I'll do is get the 3 over. So this is like right after where we root both sides when we're going the other direction. And then here I'll square to undo the plus or minus. When we're solving, we root, so then when we're working backwards, we square. So expanding this would be x squared minus 6x plus 9. There's that, the special products again. Plus or minus is gone because we squared it, so 16, and then I'm just going to say negative 16 because that I squared would make that negative. And adding this over, I get x squared minus 16x plus 25 equals 0. Okay, and these are the matched ones so I would have you try. So this is x equals negative I or positive I. So that means x equals plus or minus I. So square both sides to undo the plus minus. And x squared equals I squared, which is negative 1. So adding that over, x squared plus 1 equals 0. And then this one, x equals 2 plus or minus 5i. So just like the one I did, bring the 2 over. And then square both sides. Undo the plus minus. So this would be x squared minus 4x plus 4. And then this squared, so that'd be 25 I squared. So we'll just do negative right there and add the 25 over. Okay, last section. So we have a couple of ways we can solve this. I could do where I let y equal 2x plus 1 and then do y squared minus 3y minus 4 equals 0 and then factor. So y minus 4, y plus 1 equals 0. and I get y equals 4 and y equals -1, and then back solve. So then I can say 2x plus 1 equals 4, or 2x plus 1 equals -1, and then finish solving from there. So 2x equals 3, x equals 3 halves, and here adding or subtracting the 1 over, 2x equals -2, x equals -1. So that's one way to do it. Or if you've done enough of these now where you can kind of see, oh, this is just what multiplies to -4 and adds to be -3. Remember, the key for all of these is right here is how it's going to factor. And so when you go to set up those parentheses, like you're going to factor something, whatever's going to go here is whatever's in the middle. So this is going to be 2x plus 1, 2x plus 1. And then from there we just have to do, okay, what multiplies to -4 adds to be -3. So -4 and plus 1. So collecting 2x minus 3 and 2x plus 2. And then if I set those to 0, we're right there. 2x equals 3, and then x equals 3 halves. This would be -2, divide the 2, and there's the x equals -1. So if you can see it this way, it's a little bit nicer, but this also works. So these ones, where people go wrong on the test here is they feel like they can't get imaginary solutions because we can't get them for root equations, which are coming up. But these are polynomials, so they can absolutely have imaginary solutions, and we'll see that as we do these. So this first one is a difference of squares. It just happens to be the fourth. So it's going to be x squared plus 4 and x squared minus 4. Right here I see people go root, and they go x equals 2. Careful, that's not quite true, because it'd be plus 2 and then minus 2 if we kept factoring. So here x equals plus or minus 2. And we get that when we bring the 4 over, but when people do the root, they forget to do the plus minus. So this one doesn't factor its prime. So I'll use the square root principle. So when you bring the 4 over, x squared equals -4, and root both sides. X equals plus or minus 2i. So I had x to the 4th. I have 2 answers here, and there's my other 2 answers there. For this one, it factors. I just have to split it up as x squareds. So it's going to go x squared, and then multiplies to -40, adds to be -6. It's going to be -10 and plus 4. So from here, x squared minus 10 equals 0. X squared plus 4 equals 0. And then bring the 10 over, and then root both sides. And I get x equals plus or minus root 10. So there's my first 2 answers. And then this is the same thing I got over here, x squared plus 4. So this is just going to do the same thing and be x equals plus or minus 2i. Okay, these are the matched problems, the ones I just did. So I'm going to do this one as what I think is the easier way, where I just split it up using that as basically my x. And then we're just looking at what multiplies to -7, adds to be -6. So it's going to be a -7 and a plus 1. So this side will be 3x minus 6. Oops. Sorry. And then this will be 3x plus 2 equals 0. So if I think of solving these over, this is going to be x equals 2. And this one's going to be x equals -2/3. Number 5, so we'll do x squared, because of what's here, x squared, and we need multiplies to -14, adds to be 5, so sounds like plus 7 and minus 2. So x squared would equal -7 when I bring it over, root both sides, x equals plus or minus, that'll be I, because of the negative, root 7. Here, x squared will equal 2, root both sides, and x equals plus or minus root 2. Number 6 is the difference of squares, so 9x squared plus 1 and 9x squared minus 1. So here if I set this to 0, I'll have 9x squared plus 1 equals 0, bring the 1 over, 9x squared equals 1, negative 1, and then divide the 9, so x squared equals negative 1/9, and then I can root both sides. And so here I'm going to get x equals plus or minus, the negative will be an I, and square root 1 is 1, square root 9 is 3, so 1/3 I. And if I do the same thing here, I'm just going to get 9x squared equals positive 1, and so I'm just going to get x equals plus or minus 1/3. And you can also do it by 3x plus 1, 3x minus 1 a factor. Okay, and then these two will be back to me. Here's where I definitely like looking at that middle to tell me how it's going to factor. So this is going to split up to roots. And root x times root x gets us that x back in front. So here we just need two numbers to multiply to negative 14 and add to be positive 5. I think we just did that one, sorry. So plus 7 minus 2. But here, when I bring this over, I get root x equals negative 7. And remember, a root can never equal a negative number. So that's that piece doesn't produce a solution. Here, I get root x would equal, bringing it over, 2. And now I'm going to square both sides, because I have to undo the root. So the reverse of what we just did. And I get x equals 4. For number 8, that tells me how it's going to split. So this is going to go x plus 5, x plus 5. And then I need two numbers multiplied to positive 16, add to be negative 10. So it sounds like negative 2 and negative 8. So I'll just set each of these to 0 and solve. So x minus 5 minus 2 equals 0. Bring the 2 over. X plus 5 equals 2, and then root both sides. X plus 5 equals 4. I'm subtracting the 5, and I get x equals negative 1. And that's legit, if I put that back in, this stays positive. It's square root 4 is 2, so this is all good. And I have to do the same thing with this one. So x plus 5, I'll just write equals 8. Squares both sides, and then x plus 5 equals 64. Subtracting the 5, x equals 59. Okay, and these two would be the matched problems. So this is going to go root x plus 7 and root x minus 3. So you're going to multiplies negative 21, adds to be 4. So root x equals negative 7, nope. And then over here, root x equals 3. We just square both sides, and x equals 9. For this one, I had a thing for 14s and 5s this time. I'm not sure what the deal was. So I was probably really tired when I was writing these. So I'll just set my parentheses. Negative 14, negative 5. So this time it's going to be a negative 7 and a positive 2. So here, when I bring that over, it'll equal negative 2, which it can't. So that piece is done. And then this side, bringing that over, it'll make a positive 7. Then I can square both sides. X minus 4 equals 49, and add the 4. X equals 53.